Folks, I'm Dean Knox, Faculty Fellow of Analytics at Wharton. I'm also the founder of Research on Policing Reform and Accountability, which is an organization that aims to bring statistical rigor to the study of policing. So this is an area where policymakers are searching for effective reforms, and it's an area where certain kinds of data are increasingly available, but at the same time where our measurement and our instrumentation is incomplete. What we get to see is heavily selected. And so this is going to be a cautionary tale. What I'm going to show you is that rushing to analyze data without context can lead to some really flawed conclusions and what we can do about it. The core point I want to make is that whether in policing or elsewhere, we absolutely have to think about the data generating process. I'm going to shadow again. The core point I want to make is that whether in policing or elsewhere, we absolutely have to think about the data generating process. What we see, all the reasons we might be seeing what we see, and all the parts of the system that we don't get to see before we can begin to draw insights from that data. Now, here's what I mean by a data generating process. So if we want to know about racial discrimination in police use of force, and what I mean by that is whether a police encounter with otherwise identical minority and white civilians would result in different outcomes from the perspective of police violence, then we need to make sure that we're making apples to apples comparisons. And among other things, that means comparing groups of civilians that are engaged in comparable behavior. And that's because things like criminal activity, of course, can lead to police using more force. We also need to think about the fact that in certain neighborhoods, or at certain times of day, officers might encounter a larger or smaller proportion of minorities, which might correlate with civilian behavior. For example, because certain areas are more or less wealthy, and because officers might be more heavily armed in those neighborhoods, which might correlate with willingness to use force. But we also need to think about this context. Now, a key part of this story is that officers don't jump directly to force, typically. They may stop and question a civilian, and then if things go badly, escalate to violence. And of course, there are a lot of other things going on. There's subjective factors that can influence both of these officer decisions, like whether the officer is feeling suspicious or just plain having a bad day. And the reason this is important is because all of this pipeline determines what we get to observe. So as you'll see in a second, some datasets only record instances where the officers use force. Other datasets are based on detainment records, or the forms that police fill out when they stop and question someone. We basically never get to see the whole picture here. And even if we did get to see all of these encounters, and not just the detainments or the uses of force, officers would still almost certainly not report their state of mind. So at best, we get an incomplete picture of this complex reality. Now, before I dive into this more complex example, I want to first talk about a simpler case that many of you will be familiar with, the case of Abraham Wald and the airplanes. So as the story goes, Wald was a statistician in World War II who was given data on airplane bullet holes, their locations on a plane. And he was told to determine where to add armor for extra protection. So if you just looked at this data naively, without thinking about the data generating process that underlies it, you might conclude, well, there's a lot of holes on the wingtips, so maybe we should reinforce those. But the thing is, we don't have information on all planes, only those that made it back to base. The real story is, if you're out flying and you're shot in the engine, then you go down immediately. But if you're shot in the wingtip, you might be able to limp home. And once we realize that there's this whole picture of which we only get to see one particular perspective, it becomes clear that the real conclusion is actually the opposite of what we initially, perhaps naively, thought. We should add armor not where we see the holes, but precisely where we don't see the holes. So now let's take that idea of thinking about the whole data generating process and apply it to the study of policing. So like Wald, policing researchers have very limited measurement. We only get to see isolated perspectives on a much bigger process. And many studies in this area get tunnel vision. They only think about the data that they have in front of them, whatever they happen to be able to get, or whatever was easy to measure, and neglect the bigger picture. But understanding how all these stages fit together is absolutely critical. It's a conceptual step that's even more important than any statistical analysis. And it helps us understand why the ACLU and a police department can analyze the same data and yet come to opposite conclusions. Understanding how that fits together is going to be important to improving how we do data science. So now let's think about a toy example, a simplified mental model. This is going to be a caricature of real-world complexity, but it's going to help us distill our intuition for how this whole thing works. But let's suppose that we have a bunch of police-civilian encounters that are identical in almost every way. Obviously, in reality, there's going to be a lot of variation in these encounters, but let's just imagine that this box represents, say, every police encounter on a Wednesday in West Philly where civilians are jaywalking. And we could imagine that there are many other boxes representing Thursday or North Philly or people behaving in different ways. Now, most of these encounters will be with white civilians. Here, I'm indicating the race of the civilian, our main treatment variable, with D by convention. So most of these encounters will be with white civilians, and others will be with minorities. And among these encounters, officers can choose whether to stop or not stop. I'm just walking through that data generating process one step at a time. Now, this decision to stop is a mediating variable, which I'm denoting with M, that lies between the treatment and the outcome. And you can see here that about a quarter of the time, officers stop white civilians, 3/4 of the time they choose not to. In this hypothetical example, minorities are stopped at a different rate. About 3/4 of the time, officers detain the minority, and 1/4 of the time don't. In other words, there's discrimination in stopping by a factor of 3. 3/4 to 1/4. Now, in the last stage of this process, officers choose to either use force or not. So these force events are denoted here. The outcome Y, again by convention. The important thing here is that, again, in our hypothetical example, this happens in about 1/8 of white encounters. So 1 out of every 8 times an officer encounters a white civilian, they use force. About 1 in every quarter, they make a detainment, and then the rest of the time, no interaction happens. The civilian passes. Now, that number is going to be different in the minority encounters. About 1/4 of the time, officers detain and then use force. Again, hypothetically. And so this is going to be the ground truth. It's what we would conclude if we did have this complete view of the data. So now let's see what happens when we only get that limited perspective. And we're going to think about 2 ways that analysts can be led astray by bad data. The first is if we had something like the fatal encounters dataset or the Washington Post police shooting dataset. In other words, if out of all these cases, we only get to see the most egregious outcomes. All the times that a white civilian was shot or killed, and a black civilian or minority civilian was shot or killed. Now, to be clear, these are the events that we care about. We really do want to know how often civilians are shot. But in this scenario, what we don't know is how often that event doesn't happen. In other words, we only have the numerator in this fraction, the shooting rate among white encounters, the shooting rate among minority encounters, and we don't know the denominator, how many encounters happened overall. Now, a naive analyst might say, well, the sizes of these 2 buckets are about the same, therefore there's no discrimination. And that might sound silly at first, but this is a sentiment that we've heard from prominent commentators and even from high-ranking government officials. In America, there's more police killings of white individuals, therefore, the conclusion is there's no problem with systemic bias in policing. That's a sentiment that we hear over and over again. And obviously what folks are forgetting here is that there are just way more white civilians in America, period. In other words, the denominator is much larger. And even though this issue is easy to spot when we state it so starkly, that same logical fallacy can slip past our radar when it's dressed up in statistical terms. But just a year or so ago, there was a paper published in the Proceedings of the National Academy of Sciences, one of the most prestigious journals in the world, that did just this. There was some mildly sophisticated statistical modeling going on, but at its core, it was an analysis that was trying to predict, all else equal, whether a fatally shot civilian was more likely to be black or white. So our group, ROPRA, had to point out the obvious issue here. which ultimately led to the paper's retraction, which again is that we simply don't know the denominator for these things. And without knowing the denominator of how often the encounters happen, we're not able to make any sort of principled statement about the probability of somebody being shot in an encounter, regardless of their race. So this retraction, of course, is the ultimate black eye for an academic, and it just shows you how easy it is to be led astray by flawed data. How could we have avoided this? Recall that the issue here is this problem of the missing denominator. In other words, what proportion of encounters are with white civilians versus minority civilians, and how that compares to the proportion of killings that are of white civilians and minority civilians. And even though we don't know the answer to that, by recognizing that this is the issue that we're trying to deal with, we could try and approximating it with other outside information. For example, we could turn to just demographics of neighborhoods. Right? So we might know in West Philly that X% of residents are black or Hispanic or white. Now, of course, that doesn't mean that exactly X% of police encounters are with a particular group. That's going to depend on how active people are or where in the neighborhood officers go on patrol. But we could use those demographics to get a good sense of the plausible range. In other words, to get some approximation, this red box, to what we really care about, which is this faded blue box. The second way, I'm going to pivot now and talk about a second way that analysts can be led astray, which is by analyzing police detainment records and mistakenly thinking that they're getting a complete picture. So thinking back to our bird's eye view of the data, what that would be doing is essentially throwing away all of these non-stops that don't appear in the detainment records. Now, in reality, just because you have all the police records doesn't mean you're free from this issue of selection bias, because these records have discrimination built in. They're contaminated from the start. In other words, there are all these stops of minorities that would not have occurred if that same person, if that same encounter had been with otherwise identical white civilian. For example, there was a prominent paper by a Harvard economist, Roland Fryer, that fell into precisely this trap when analyzing NYPD stop and frisk data. So if we apply this logic in our hypothetical case, we'd find that 50% of white stops, of white detainment records, involve force. In other words, this proportion out of what we get to see is 50%. But only 1/3 of black stops, these events here, out of what we get to see, involve force. In other words, there's the illusion of less violence against minorities in the subset of encounters that we get to observe. But in fact, the reality is the opposite. When we think about what we really care about, a fraction of all otherwise identical encounters, then white force rates are much smaller. Force is used on black civilians at twice the rate. The fallacy creeps in when we erroneously use only what we can see, these police records, the M=1 cases here and here, as our denominator, when the real denominator should be all encounters, both seen in this red box and unseen, faded out. Our group has a number of papers that present careful mathematical derivations that show, under a number of conditions, that if there's discrimination against minorities in this initial stop stage, and if that leads to an inflated number of minority stops for low severity things like jaywalking, again, these are all fairly plausible approximations to reality. Right? And then you think about the white stops, which tend to be initiated for only more high severity behavior. And now we reflect on the fact that officers are probably less likely to use force in these excess low severity situations, these jaywalking stops, the excess stops of minorities, then doing this naive analysis under these conditions and assumptions is guaranteed to produce an underestimate of discrimination. And that's a useful result. By combining this process-oriented reasoning with a statistical analysis, it allows us to say that even though we don't know the true extent of the problem, it must be at least this bad and probably much worse. In other words, we can get a lower bound on the severity of the problem. And depending on what we're trying to do, that may be enough. Now, I'll stop there. Here's a few of these papers that our work is based on. You can find all of these and others on our website, policingresearch.org. Thanks again.